There we go. Okie dokie. Yesterday, yesterday we talked about what the compass headings are. So we're not going to reproduce the whole thing, but just in general, we have 0, 90, 180, and 270, right? Everyone remembers that from yesterday? So this problem says a ship leaves port and travels 15 miles on a course of 100 degrees. So we're going to draw this picture. Now, where are we going to put 100 degrees? A course of 100 degrees. Well, isn't it going to be a little bit past 90? So we're going to draw our vector, our ray, right there. And this is 100 degrees. Now, I'm not measuring anything. This is approximate. But get it in the right quadrant. Get it down there in the fourth quadrant. And I know that ray I just drew is 15 miles long. Would you agree with that? All right. Now what happens? What happens is we change course. So I'm going to, now my ship is right here. So I'm going to set up a new compass. And now I'm going to send him out on a course of 200 degrees. Now, where is 200 degrees going to be? Remember, this is 0 and 180, right? And 90 is over here. So won't this be 200, like right here? And that one is just 2 miles. So that one's going to be a short little thing. There he is, right there, 2 miles. Would you be able to draw that? Okay. Now, that's it. Problem done, finished. But let me tell you where we're going. By the end of the chapter, what will happen is, okay, here's this ship. He goes out and he starts sailing around. And then when he gets here, all of a sudden, he starts sinking. So he radios for help, and we have to send a rescue helicopter out from port to get to him. So we're going to learn, using trigonometry, how to figure out what course the rescue guy needs to take and how far he needs to travel. So that's where we're heading with this. But right now, all you're responsible for is drawing the course. So as long as you have this drawing, you're all good. All right? All righty, 4.1 due on Thursday. Let's move on to 4.2. Get out your, what color are your sheets? Orange? Get out your orange sheets. I need them today. So we have a handy dandy right triangle one. And the directions say, find the value of all 6 trig functions. Now, your 6 trig functions, they're all listed there, are the sine, and the cosine, and the tangent. Those are what we refer to as the big 3. Those are the ones that are on your calculator. You have a button that says sine, cosine, and tangent. But there are 3 others that are the reciprocals of these. The reciprocal of the sine is the cosecant. All this information is on your orange sheet. The cosecant. The reciprocal of the cosine is the secant, and the reciprocal of the tangent is the cotangent. Now remember yesterday, I told you need to know what's on at least the front of this orange sheet, right? And I told you you didn't have to memorize by today, but you need to start learning this stuff. So you need to start learning, first of all, SIN is the abbreviation for sine, cosine, tangent, and then their reciprocals, cosecant, secant, and cotangent. it looks overwhelming if you haven't started studying yet, but when you start studying it, you'll see it. This is so easy, so easy. Who remembers SOHCAHTOA? Everybody, hopefully? So you can write that on your sheet if you want. That orange sheet is yours. You can write on it, write SOHCAHTOA on it if you want to. Take whatever notes you want on it. That's your sheet. Stuff you need to learn. What does this mean? S, C, and T stand for sine, cosine, and tangent. What does the OH represent? Opposite and hypotenuse, and adjacent and hypotenuse, and then opposite and adjacent. Now, here's a key thing. Somewhere in your picture is going to be the important angle, and in this case it's theta. Theta is the angle that's in our problem, theta, right there it is. Relative to that angle, you need to figure out which side is opposite, which side is adjacent, which side is hypotenuse. Now, the hypotenuse is the easy one. We're not going to get confused about what the hypotenuse is, right? It's the slanted one. But now you got to figure out, because it's going to change from problem to problem, which one is opposite and which one is adjacent. If the angle is right here, then this side is opposite because it is across from the angle. This side is adjacent because it is next to the angle. Once you've labeled that, you're home free. What's the sign? By definition, what's the sign? Opposite over hypotenuse. So 2 over root 13. What's the cosine? Adjacent over hypotenuse. And what's the tangent? Opposite over adjacent. See how easy that is? And then these guys are just the reciprocals of what you already did. So flip it. So the cosecant is going to be root 13 over 2. The secant is going to be root 13 over 3. And the cotangent is going to be 3 halves. Now I want you to look at all 6 of your answers and tell me if I need to fix any of them. So by fixing, I mean sometimes we can reduce. Sometimes we have issues like this. What's wrong with that? There's a root in the bottom, right? We don't like that. So that one needs fixed. So does that one. I think the rest of them are okay. All right, so how do we fix this? Remember, you multiply top and bottom by the radical. So what do I end up with? 2 radical 13 over what? What happens when I multiply those 2 together? Just 13. Just 13. Yeah, that's the whole point. I want a plain 13, not a square root. So I'll do the same thing here. So 3 root 13 over 13. And the problem's done. What do you think, okay? Well, I hope you enjoyed it because we got another one. So now I have a triangle. That looks like this. And I'm going to do the same exact thing. I'm going to find sine, cosine, tangent, cosecant, secant, and cotangent. All right, and this is my picture this time. So before we start, let's label our sides. Which one's the hypotenuse? 5, 12, or 13? 13. Now pay attention. There's your angle. Which one's opposite? 5. Very good. Why is 5 opposite? Because it's the one directly across from the angle. Opposite the angle, on the opposite side of the triangle. All right, now we can fill them in. We're going to be radicals this time, so it's going to be easy. Sine is opposite over hypotenuse, so 5/13. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Does that look okay to everybody? And how do we find the other 3? We just flip them over. So the cosecant is going to be 13/5. Secant is going to be 13/12. And cotangent is going to be 12/5. Everybody good? All right, let's look at C. Well, first of all, you're going to have to write down the functions yourself, because I didn't do that. So you're going to still find all these things, but you have to write it out yourself. Yes. Now, if you don't want to use theta, you can use something else. Okay, my friends? So you gotta write these down yourself. You're finding all those things, so get those written down. And then, we have a problem. What's kind of wrong here?
No hypotenuse.
No hypotenuse, we're missing a side. We're missing a side. We gotta have it, you gotta have all 3 sides to answer these questions. So, who remembers how we might find, I'll just call it X for now. How might we find X?
So, formulas of a squared plus b plus c squared.
A squared plus b squared equals c squared. What do we call that? That's called the Pythagorean theorem. And caution, caution, caution. When you do the Pythagorean theorem, this is the hypotenuse. The one that's all by itself is the hypotenuse. Always. So we're going to have 1 squared plus 3 squared equals x squared. Do you agree with that? So 1 plus 9 is 10. So what's my hypotenuse? Not 100. Going to be the square root of 10. Got a square root. Everybody good with that number? Obviously, if you miss that number, you're going to miss a bunch of answers, so you got to make sure we got that right. Square root of 10. X squared equals 10.
Oh.
So x equals the square root of 10, and you know what x is. All right, now, before you start filling stuff in, label opposite, adjacent, and hypotenuse. So what's the one? Adjacent. You guys are really good at this. What's the 3? Opposite, and of course root 10 is the hypotenuse. All right, see if you can fill them in. Go ahead and fill them in using that triangle right there. Go ahead and fill them in and see what you come up with. sign?
Over square root 10, but then you can't have it, so I did 3 square root 10 over 10.
Beautiful, beautiful. So her first thought was opposite over hypotenuse. Then she cleaned it up because of the radical. And did you do the same thing with this one?
Yeah, so then it's square root 10 over 10.
And then what about tangent?
3 over 1.
And of course, 3 over 1 can be written as just plain 3. All right, now we do the reciprocals. Hint, when you flip, flip here. Because if you flip this, you get root 10 over 3, which is fine. If you flipped here, you'd have a radical in the bottom that you'd have to fix. So flip it here. And flip this one here, root 10 over 1, or just root 10, and 1/3. Everybody doing okay? All right, with your partner, would you do the last one? Do with your partner. Check answers with your partner.
I don't think it's like 2 squared guys. Yeah. So you have to solve for the opposite.
Whatever this thing's pointing to, yeah.
The opposite.
Yeah.
Yeah, but instead of
And the long
the
one.
x would be this side. No, because isn't it what's across from that?
What are you doing? Is the D?
How do you find the,
Oh, I thought you meant like those.
It's the same thing. It's 2 squared plus 2 squared.
which one's a squared?
A squared is adjacent, which is the 2.
2.
Yeah, 29.
For the opposite.
Oh, I forgot to square 5.
Am I supposed to? Oh, yeah. Yeah, I also got that. Yeah.
I did get
Yeah. That's why I was thinking they kept that.
All right, I'm hearing some things that sound great, and I'm hearing some things that are making my eye twitch. So we're gonna check on something first. We have a missing side, don't we? We know we're gonna use the Pythagorean theorem. Which side is the hypotenuse? So it is by itself. So 2 squared plus x squared equals 5 squared. That's how your Pythagorean theorem has to be set up. The hypotenuse is the one that is by itself. So you should have gotten the square root of 21 as your missing side. Is there anybody that's got a question about that? Screw up the side, 4 of your answers will be wrong. So we gotta get that right. Did we get it?
Wait, yeah.
All right, so that's gonna be root 21 right here. Now, the next thing I want you to do is to label the sides. I've already labeled this hypotenuse. What's this one?
Adjacent.
Adjacent, and this one then is
Opposite.
opposite.
Yeah.
So now it's just a matter of SOHCAHTOA.
Minus the 4.
So sine is root 21 over 5. Cosine is 2/5. And tangent is root 21 over 2. How does that look to everybody? Good? Now we simply flip them. You gotta know, because it's not always gonna be set up like this. You have to know that the reciprocal of the sine is the cosecant, okay? Because it's one of the things you have to be memorizing. So 5 over root 21, 5 over 2, and 2 over root 21. And then, of course, we've got some radicals down there that we don't want to have down there. So we'll fix that. Multiply top and bottom by root 21. So 5 root 21 over 21. Now, most of you are going to go straight from here to here. You don't have to show that work. I'm showing it in case there are some of you that forgot how to do it. And then this one's going to be 2 root 21 over 21. Does anybody have a question about that? We're all good? Yep.
Did you get a fine who's the opposite?
You thought it was what?
Like opposite.
Okay, cosecant
Oh, yeah.
is the reciprocal of the sine. So whatever you wrote down here, hopefully you wrote opposite over hypotenuse. This is gonna be hypotenuse over opposite. All right, now let's look at the next one. The next one is actually exactly the same thing, except instead of drawing, there's no numbers drawn on the picture. The picture is drawn for you. Put theta at the origin always. Theta always goes to the origin when you have a picture that's set up like this. And then notice that we're told what the sign is. So there's nothing in my picture, but I'm told that the sign is 2/3. Well, first of all, the easiest points ever, what's the cosecant? 3 over 2. And we don't even need to do any work at all to know that. What's sine again? Sine is opposite over hypotenuse. So whatever's happening in this picture, the opposite side must be 2 and the hypotenuse is 3. Now, this is my angle. Okay, no negotiation, that's where we put it, right at the origin. I know this is the hypotenuse, so that's gonna be 3. Which side's the opposite? This one or this one?
Say opposite.
1 or 2?
Two.
2. That's the opposite side. Would everyone agree with that? This is opposite. So it's the adjacent side that I'm missing. But I know how to fix that. I just got done doing it, right? So what's my Pythagorean theorem gonna look like?
3 squared.
No. 2 squared plus x squared equals 3 squared. In the Pythagorean theorem, one number is by itself. That number has to be the hypotenuse. Could this be x squared plus 2 squared? Yes, that doesn't matter one bit. The order. All right, so 4 plus x squared equals 9. Looks to me like x is gonna equal the square root of 5. All right, now we can fill them in. It's just like what we've been doing, so we can fill them in. Cosine is root 5 over 3 adjacent over hypotenuse. Stop me if I say something that's either wrong or you don't understand. And then tangent is opposite over adjacent 2 over root 5. Now I know I'm gonna have to fix that one. I can fix it now, or I can fix it later. As long as I fix it, it doesn't matter. Secant is 3 over root 5. Secant is the flip of the cosine, the reciprocal of the cosine. And then cotangent is. Anybody have a question about that? Well, let's look at the next one. It is exactly the same situation, except what do we know this time? I don't know why I didn't mark theta. Mark theta at the origin again. Theta is at the origin. And this time, what do I know? I know the cotangent is 1/4, which automatically means the tangent is 4 over 1. Now what does that mean in terms of my picture? Opposite over adjacent is 4 over 1. So opposite is 4 and adjacent is 1. Everybody on board? So in the picture, here's my hypotenuse. What's this? Opposite and adjacent. So 4 and 1. All right, what do we do now? Okay, go ahead and do it all by yourselves. And tell me what you think the hypotenuse is. What do you think? Square root of 17. 17? Talia says square root of 17. Grayson's nodding. Everybody good with square root of 17? All right, then here we go. So, Katoa, opposite over hypotenuse, adjacent over hypotenuse, and he's already done. We're going and clean up anything that needs cleaned up. So, what's this gonna be? 4 root 17 over 17, beautiful. And this is gonna be root 17 over 17? Yep. Everyone okay? But here's what we're gonna do now then. There are 2 more. For each of them, I want you to start with the same picture that we have been starting with. All right, start with that picture for C and D. I want you and your teammate to figure those out, and then I want you to come up and put your answers on the board. All right? So take a second now and go over C and D with your partner. Oh, because
on the bottom, so it's up.
Adjacent over adjacent, so the adjacent square.
Like,
Too much, just like a
Oh wait, no, right. Wait, no, you're wrong. This
Yeah, yeah, that's what I got.
Maybe the 502.
When you think you got answers, bring them on up. We'll put C over there, D here.
Like when it means
Remember, boys and girls, when you square the square root of 5, you just get 5. Square root of 5 squared is 5.
I use the calculator for that one. Opposite look at my questions. What I'm doing. What is this sec? I should try
We just do the same thing we did last time.
Oh, logarithm,
No, it'd just be one. It'd just be one. It would be x squared
Okay, this next one is that, right? This sec and then what is this? J over
It's just so it's just the reciprocal. Wait.
Oh, right.
If they're reciprocal, they might not be.
When you did your Pythagorean theorem for problem C, did you get the square root of 4?
oh, I'm sorry.
I hope you wrote that as 2. Right?
So, like right here. So for that.
If she means in the present,
What's the opposite?
these are all.
Oh, this one does it, this one does it,
So let's try this.
It's literally just the opposite. This row is the opposite.
So 4 over 5.
Yeah.
Like green is 7 like.
Yeah.
Okay.
Or you would have to do this.
So everything else is right?
Yeah.
I don't
You
know
just
where
have
we
to
are.
All right, everybody's done up here. You may not be done, but I really want you to make sure you got C correct. D because there's all kinds of different places you can make mistakes.
That was our
So, this is what was given in problem C. So adjacent over hypotenuse. Adjacent is root 5, hypotenuse is 3. Now, this was the missing piece, and she got it right, but I'm gonna walk through it with you. The Pythagorean theorem says root 5 squared plus x squared equals 3 squared. That's what it says. When you square root 5, you just get 5. Plus x squared equals 9. So x squared equals 4. And x equals the square root of 4, which no self-respecting mathematician writes. What's the square root of 4? 2. So x is 2. And that's what she had. And that's how she built her problem. And I think, I didn't check it, but I think it's all correct. Does anybody have a question about problem C? How many of you got it right? All the way right, everything right.
Almost.
Almost doesn't count. Almost. Okay. This one should look familiar. I think these answers are exactly the same as the answers to problem B. I think. The given was different, but the setup was the same, the picture was the same. Anybody have a question about that? Okay, this is so easy to get a little quiz over, right? So easy. All right, now we're gonna switch gears and move on to question number 3, which is a little bit different. You need your orange sheets for sure. Let's see if we can make sense of this. All right, well, our job is without a calculator. Find the sine of pi over 6. I want you to think back to yesterday. Pi over 6 is a radian measure. Can anybody tell me how many degrees that is? Okay. Well, pi is 180. Pi is 180. So what would pi over 6 be? 30. Remember that from yesterday? A whole pi is 180. So if all we had was that, it would be 180. But we're dividing it by 6, so it's 180 divided by 6, which is 30. So we're finding the sine of 30 degrees. We're going to do it without a calculator. So, first thing you do is draw a picture exactly like you did for the last few problems. And remember in the last few problems, it was sine theta. And where did we put theta? At the origin. This time it's sine 30. Guess where we're putting 30? Right here at the origin. Okay? Now, if that's 30, and that obviously is 90, then what's that?
120.
The angles of a triangle add up to 180. So that's 90 already. And that's another 30. 60. Do you remember from geometry talking about 30, 60, 90 triangles? Well, Kids, those are important and you need to remember them. But to help you, look down at the bottom of your orange sheet. You should see a triangle down there that has a 30 and a 60 and a 90 in it. Now, it's not set up exactly like this one, but is it a triangle with a 30 and a 60 and a 90? Okay, so what you need to remember is, what's on the sheet, and you need to remember is, every single time you got a 30, 60, 90, opposite the 30 is going to be a 1. Never changes. 1 across from the 30. Across from the 60 is root 3, and across from the 90 is 2. Those are the ratios you learned in geometry, but I know that's been a while and you probably forgot. But those numbers those are facts. That isn't going to change. You're going to memorize that across from the 30 is 1. Wherever the 30 is in the picture, across from it is 1. Across from the 60 is root 3, and the hypotenuse is 2. Every time. Now there's your angle. Remember, it's the one at the origin that is the big one, the big deal. That's the big deal. So this side would be the opposite side. Would you agree with me? This side is the adjacent, and this side is the hypotenuse. Now we want sine. So, katoa. What's sine? Opposite over hypotenuse. Look at your picture. Opposite over hypotenuse is 1/2. And that's the answer to the question. Now, if you have your calculator handy, type sine 30. And guess what it's going to say? It's going to say 0.5. Anybody not say 0.5? Sine 30? We are doing it without a calculator, but we're gonna get the same answers as the calculator.
Do you need to close the calculator?
Now, let me see what it says. All right, let's look at number 2. Tangent, pi over 4. Okay? So who remembers, what's the first thing we're probably gonna wanna do? Change that pi over 4 into a degree measure. So keeping in mind that pi is 180, pi over 4 will be 45. So we're going to find the tangent of 45 degrees. We're going to draw the same picture that we've drawn in the last few problems. That's going to be our picture. And instead of putting theta here, I'm going to put 45 here. And that becomes my big important angle now. If that's 45 and that's 90, what's that one? 45. You can, remember, you can look at your orange sheet. Across from the 45s is 1, and the hypotenuse is root 2. I told you yesterday, there's a lot to memorize, but once you have it memorized, these problems are a cinch. We want the tangent. Tangent is opposite over adjacent. So I just need to look at my triangle. Remember, this is the angle. So isn't this opposite and adjacent? So what's the tangent of 45? 1 over 1. This is so cool. Secant, pi over 3. Step 1. Julia, let's pick on our new friend, Julia. What's the first step, Julia?
It's the secant of 60.
Yeah, she wasn't even here yesterday, and she knows pi is 180, so pi over 3 will be 60. All right. Now I'm going to draw my picture. Don't try to do this without a picture, you guys. Draw a picture. You're going to put your 60 right here, right? Always put your angle at the origin. And then the 60 is there, so this must be the 30. The only two special angles, or special triangles you're responsible for are the two that we've used. 30, 60, 90, 45, 45, 90. Here we go, gotta label these sides. Across from the 30 is always 1. Across from the 60 is always 3, and the hypotenuse is always 2 in a 30, 60, 90. Here's my opposite, my adjacent, my hypotenuse. All good? Secant. Secant is the reciprocal of what? If you don't remember, it's on your sheet, look at it. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, right? So what will the secant be? Hypotenuse over adjacent? So hypotenuse over adjacent, the answer to that question is 2 over 1. 2. Did you follow my thought process? All right, there's one more. Cotangent pi over 6, give it a shot. Oh, I guess it's a couple more pages, but this will be there. Vanessa, what's the very first thing you're doing? Okay, did everybody hear what she said? She said she changed pi over 6 into 30. Because you gotta do that so you know which triangle to draw. You need to know your angle, so it's a 30. Okay? So, hopefully you set up a picture that looked like that. This one up here is 60. And now we're going to label our sides. What are our sides? Over here is 1. Here is 33. And here is 2. You want cotangent. Oh boy. Cotangent is reciprocal of tangent. Tangent is TOA. Tangent is opposite over adjacent. So cotangent will be adjacent over opposite. Which side's adjacent? Root 3. That's adjacent. So we have root 3 over 1, or just plain old root 3. All right? That feel okay? All right. Now you can run to the bathroom, but you gotta be back by prayer, so you gotta run fast. Hurry up, Ross.